Introduction to CAD Design. What is a computer-aided design? Computer-aided design, CAD, is a computer technology that designs a product and documents the design's process. The CAD may facilitate the manufacturing process by transferring detailed diagrams of a product's materials, processes, tolerances and dimensions with specific conventions for the product in question. It can be used to produce either two-dimensional or three-dimensional diagrams, which can then, when rotated, to be viewed from any angle, even from the inside looking out. A special printer or plotter is usually required for printing professional design renderings. The concept of designing geometric shapes for objects is very similar to CAD. It is called Computer-Aided Geometric Design, CAGD. CAD is also known as Computer-Aided Design and Drafting, CADD. CAD is used as follows. To produce detailed engineering designs through 3D and 2D drawings of the physical components of manufactured products. To create a conceptual design, product layout, strength and dynamic analysis of assembly and the manufacturing processes themselves. To prepare environmental impact reports, in which computer-aided designs are used in photographs to produce a rendering of the appearance when the new structures are built. CAD systems exist today for all of the major computer platforms, including Windows, Linux, Unix and Mac OS X. The user interface generally centers on a computer mouse, but a pen and digitizing graphics tablet can also be used. View manipulation can be accomplished with a space mouse. Some systems allow stereoscopic glasses for viewing 3D models. Most UK universities no longer require classes for producing hand drawings using protractors and compasses. Instead, there are many classes on different types of CAD software. Because hardware and software costs are decreasing, universities and manufacturers now train students on how to use these high-level tools. These tools have also modified design workflows to make them more efficient, lowering these training costs even further. History of computer-aided design. CAD began in 1957 when Patrick J. Hanratty developed Pronto. Pronto was the world's first commercial numerical control programming system. In fact, designers today say that Dr. Hanratty was the father of CAD or CAM. Ivan Sutherland, of MIT's Lincoln Laboratory, designed the Sketchpad in 1960. Sutherland demonstrated the basic principles and feasibility of technical drawing using a computer. Initially, CAD systems were simply replacements of drawing boards. Design engineers still worked in 2 dimensions to create technical drawings. Even so, with these early systems, it was easier to modify and revise one's work. Initially, these systems were extremely expensive. Therefore, only large and rich companies had them. However, over time, CAD software and hardware became more affordable for medium-sized firms. Affordable means within most consumers' budgets. In this case, the consumers are firms. 3D wireframe features were developed in the 1960s. In 1969, Synthavision released Magi, the first commercially available solid modeler program. The use of the mathematical model NURBS in computer graphics for generating and representing curves and surfaces emerged in 1989 on Silicon Graphics workstations. NURBS stands for Non-Uniform Rational Basis Spline. Cas-Berlin developed an interactive NURBS for personal computers NURBS in 1993. In 1989, T-Flex introduced CADs based on parametric engines. With parametric modeling, parameters define the model. If you change dimension values in one place, changes automatically occur in other dimensions. They change to preserve how all the elements in the design relate to one another. MCAD, Mechanical Computer-Aided Design, systems introduced the concept of constraints that enable the designer to define relations between different components in the assembly. Designers began to use a bottom-up approach. In other words, when parts are first created and then assembled. People use CAD systems extensively today. In fact, we use them across all industries. These systems once only worked in expensive workstations using Unix operating systems. However, today they are available off the shelf for use in PCs, laptops, tablets, and smartphones. Three-dimensional modeling is the norm today. In fact, it even exists in applications for the general public. Examples include three-dimensional buildings modeling in Google Maps, garden planning, and interior design. For employees in many industries, CAD is an integral part of the work they do. In fact, some of them would not be able to function in our current business environment without CAD systems. Importance and impacts of CAD. The CAD software is being used on a large-scale basis by a number of engineering professionals and firms for various applications. The most common application of CAD software is designing and drafting. Here are some of the benefits of implementing CAD systems in companies. Increase in the productivity of the designer. The CAD software helps the designer in visualizing the final product that is to be made, its sub-assemblies and the constituent parts. The product can also be given animation and see how the actual product will work, thus helping the designer to immediately make the modifications if required. CAD software helps a designer in synthesizing, analyzing, and documenting the design. Improve the quality of the design. With the CAD software, the designing professionals are offered a large number of tools that help in carrying out a thorough engineering analysis of the proposed design. The tools also help designers to consider a large number of investigations. Since the CAD systems offer greater accuracy, the errors are reduced drastically in the designed product, leading to better design. Better communications. The next important part after designing is making the drawings. With CAD software, better and standardized drawings can be made easily. The CAD software helps in better documentation of the design, fewer drawing errors, and greater legibility. Creating documentation of the designing. Creating the documentation of designing is one of the most important parts of designing, and this can be made very conveniently by the CAD software. The documentation of designing includes geometries and dimensions of the product, its sub-assemblies and its components, material specifications for the components, bill of materials for the components, etc. Creating the database for manufacturing. When creating the data for the documentation of the designing, most of the data for manufacturing is also created, like products and component drawings, material required for the components, their dimensions, shape, etc. Saving of design data and drawings. All the data used for designing can easily be saved and used for future reference, thus, certain components don't have to be designed again and again. Similarly, the drawings can also be saved, and any number of copies can be printed whenever required. Some of the component drawings can be standardized and be used whenever required in any future drawings. Although CAD has been shown to aid in the development of design skills, there are pieces of evidence that CAD infiltration in design education is resulting in good design skills being supplanted by good computer skills. The infiltration and emphasis on CAD, and the isolated nature of traditional CAD work, has also been shown to undermine the beneficial aspects of peer-to-peer, and peer-to-teacher collaboration and interaction. This face-to-face social interaction is widely held as an important element of design education. Assessment of design skill development traditionally happens on a continual basis and has centered, for at least the last 100 years. Although the awarding of formal grades in respect to perceived achievement embodies aspects of behavioral psychology, the physical processes of social interaction, engagement, constructive dialogue, collaboration and reflection encompass many positive elements of social constructivism. A criticism of CAD use by students concerning this activity, particularly in the early stages of design development, is that it reduces the volume of material available for discussion, thus undermining the potential value of any constructivist engagement. The evidence of negative impact is further strengthened by general perceptions among many design educators that CAD is merely a tool for enhancing good design. CAD has also been criticized for creating the illusion of completeness and precision, which has been shown to discourage further exploration of design ideas. Most use CAD software. The software can be highly specific. It is designed to be a technical tool with functions in industrial design, mechanical design, architecture, and areas such as aerospace engineering and astronautics. A CAD model will contain data like material properties, dimensions, tolerance and manufacturing process-specific information. Furthermore, many CAD applications now offer advanced rendering and animation capabilities to better visualize product design. Some of the most used CAD software are Tinkercad. This is an online 3D design app geared towards complete beginners coming from Autodesk. The software features an intuitive block building concept, allowing you to develop models from a set of basic shapes. The online software comes with a library of millions of files that users can use to find shapes that suit them best and manipulate them as they wish. It also has a direct interaction with third-party printing services. It is quite a simplistic program and will have limitations for some designs. However, it is aimed mostly at people with no experience whatsoever with 3D modeling. FreeCAD. FreeCAD is a completely free parametric 2D and 3D modeling tool that is open source and enables you to design real-life objects of any size. The parametric component makes editing easier. You can go to your model's history and change the parameters to get a different model. This software is not designed for professional purposes, but it is a good training tool. The options it offers are quite basic but a good starting point when you have no experience. BlocksCAD. This 3D software is specifically created for educational purposes. Its development is done so that anyone can later use OpenSCAD, a more professional CAD software. The commands for the development of the objects and their transformations are represented by color blocks, reminiscent of the well-known construction toys, Lego. BlocksCAD's code is fully compatible with OpenSCAD, so you can give your models the last touch-up on there. Export formats can be OpenSCAD. SolidWorks, published by Dassault Systems, it is often used by professional 3D designers. It is a parametric feature-based model. The software includes a wide range of features such as design validation tools, or reverse engineering. It tends to be used for industrial objects. It is quite practical and detailed. One of its special features is that unlike many other software that mimic curves through gently inclining flat structures, SolidWorks uses a system of NURBS. This system allows creating very detailed curvatures. Also, instead of polygonal modeling, it uses dimensional sketching so that resizing becomes far less of a hassle. One disadvantage that is often brought up by users of the software is the limited ability to import. AutoCAD. AutoCAD software from Autodesk was one of the first CAD software to be released on the market in 1982, making it a very established CAD software across industries. Even though AutoCAD is popular and widely used in the 3D printing community, its popularity has decreased lately. Many users cite that although it is ideal for 2D drafting, it is not the easiest to use for 3D modeling. Indeed, the learning curve to master macros and scripts is steep for moving beyond simple parts. The software is aimed at professionals with experience in programming models algorithmically. If you have that skill, there is little you can't do with AutoCAD. The 3D models can readily be converted to STL files for 3D printing. Since 2010, AutoCAD was released on mobile and web app as well, called AutoCAD 360. TFlexCAD. TFlex cuts down design steps by making changes that propagate instantly throughout your design, incorporating superior design engines for adaptivity ends. This functionality helps you, for example, associated parts in a way that allows the change of one part to drive changes in associated parts. Anything in TFlex can be related to anything else. Variables can be assigned at any time for component names, visibility, material, any numeric or text attribute of any entity. They can then be processed with any algebraic or logical expression to control the behavior of a design.